It's application time. See, apply. Motion. I know these aren't funny, guys, but I'm trying. And that's what I want you to recognize. I'm already aware it's not funny. So we are going to talk about an application today. We're going to be talking about cryptography. Now, here's the big thing that I would say with all this is that cryptography is how can I? Ellen, I want to make sure that I don't I don't under or oversell this. Cryptography is the most important thing in your life. Yes, I stand by that statement. 173%. Because here's what I will tell you: without cryptography, the internet would be useless. Because nothing would be secure. Anyone could steal anything in terms of your information that you put online. Like, without cryptography, I was like, anyone can do anything. So, a little bit, here's the thing I want you to understand. All right, I got to explain a little bit how the internet works. Some of you guys are like, I know this, Mr. Keith. Great. Some of you guys, maybe not. So here's the thing. So you have your Chromebook, your computer, whatever you want to call it. You have this over here, and then there are servers that have all the information that you need right there. And then the company, like, they program into the servers and all that stuff. So you communicate with the servers. So here's the thing. So your computer's here, the server's here, and then the information that is in your computer that you're sending, I was like, goes to that server. Here's what I want to tell you. Literally anyone can just pluck your information. Like right here, just all the information going. I go, I look at it, and then I go, oh, okay, and then I send it. So that snap that you send, anyone along the internet can just go, look at it, oh, okay, let it be on its way, and then it goes to whoever's supposed to receive it or whatever. Like, anybody can just grab that information. Literally, that's how the internet works. Like, I'm not joking. That's not hyperbole or anything like that. Anything that you send can just be grabbed. Now, where cryptography comes into play is from your computer, that information gets encoded. It gets encrypted in a certain way. So that way when it gets sent, somebody goes and looks at it, they go, I don't know what this is. I can't tell. And then it just goes on its way. Okay? That's what cryptography does, is it protects your information. It makes sure that what you put in can only be seen by the person who sent it and the person who receives it. Now, who cares? If somebody sees your snap that you sent out, somebody sees your Instagram post that you didn't okay, like, who cares, right? I was like, because honestly, here's the thing. Unless there's some personal thing going on or something like that, I was like, oh, I had eggs for breakfast. Who cares? Who cares that somebody grabbed that? That's not what we care about. I was like, especially if there's one thing that this last year has probably taught a lot of us, it's the importance of online retail, online shopping. So with that, here's the thing. Who cares if I sent some message on Facebook? I know it's dated. I don't care. But who cares if somebody sees that right there? Who cares if someone can just pluck your Facebook post out, look at it, be like, oh, I know what someone's having for dinner. Like, who cares? But credit card information, now we do care. Now we do want to make sure that our credit card information that's being sent from our home computer to the server, so that way Amazon can make sure that we get whatever we're purchasing from Amazon. I was like, we want to make sure that is safe. I don't want anyone to just grab my credit card information and go, oh, now I can use your credit card. We want to make sure all that stuff's safe. That's why cryptography is the most important thing in your life. Now, I know, Mr. Keith, where's the joke there? I was like, you usually have this buildup, and there's a joke there. There's no joke this time. 100% serious. Now, what we're going over today, this is the bare surface of cryptography. That's what I want you guys to understand, is that there is a lot more to cryptography than what I'm showing you. I am showing you kind of the bare bones idea of what cryptography is and why we want to make sure that, we might not need to be like, hey, that's like, I can do that. We need to go like, hey, I'm thankful that someone can do that and keep my stuff safe. All right, so I went ahead and I just picked a word. I picked help. I don't know why. I just picked it, totally random. And we're going to go ahead and we're going to encrypt that information. So I typed the word help. Let's say that's my password, help. And I send that, and I want to make sure that no one else can see my password. So on my end, what's going to happen is this is going to get encrypted. This is going to get encrypted so that way when it goes through cyberspace, if anybody were to just go ahead and grab that, they can go ahead and they would have no clue what's going on. So realize that everything we do boils down to numbers. I was like, that's it. Whenever we type the word help, we're not really typing the word help. We're typing in a series of numbers, and when you hit that H on the keyboard, what's really happening is it's saying, hey, trigger this number, and then when the screen pops up, it says, oh, well, whenever this number is selected, like display this thing. Okay, so that's happening here. So we have an H. I'm going to just A is 1, B is 2, C is 3, D is 4. I'm just going to go ahead and I'm going to use that right there. So H, A, B, C, D, E, F, G, H. So we have 8, 5, 12. See, N is 14, O is 15. This is 16 here. Now, the encrypting matrix I'm using, I'm just going to use a simple 2x2 encrypting matrix. So we have that right there. So I'll go ahead and right here, I'm going to chunk this into simple 1x2 matrices. So I have 8 and more space there, 5 and 12, 16. So I'm going to take this, in order to encrypt it, I'm going to go ahead and I'm going to multiply this times 5, 3, 3, 2. Okay, and I'll do the same thing to this guy right here. 5, 3, 3, 2. So 40, 15, 40 and 15 is 55. 24 and 10, 34 equals. And then right here, 60 and 48. And then 36 and 32, 65. So this right here is what's flying through cyberspace. So this right here, if someone were to look at that, they would have no clue what that actually is. So as that flies through cyberspace there, now the person over here, they need to be able to read it. They need to be able to decrypt this information. Okay, you might also hear the words encode and decode. I might slip those in there. They're synonyms in this case. So right here, we need to take that 55, 103. Did I add one? That was 60. That was 48. No, 108. Okay, I wrote this number wrong. I'm just gonna say I wrote it wrong. Like I have to believe me that I did that. All right. So now the person who received the message, they have the decrypting matrix. So they have this guy right here, 2, -3, -3, 5. Now some of you guys might be going, I think I know what's going on here, and you might. And if you do, great. So right here, now in order to decrypt this message, I'm going to take this 2, -3, -3, 5, and I'm just going to multiply that. 2, -3, -3, 5. right here. So these numbers are a little bit bigger. I'll grab a calculator just to make sure. A, B, C, D, E, F, G, H. That's 8. Okay. I would have gone 16, 13, M, N, O, P, 16. Yeah. I don't know. I'm doubting myself for some reason. All right. We got 110, and that's going to be minus 3 times 34. So right here we have 8, and then negative 3 times 55 plus 34 times 5. 34 times 5 is 5. And then let's see, that's 216 minus 3 times 65. All right, what the heck did I do, guys? I should have got 103 here. Why? How did I mess up? Did I copy something down wrong? 533 there. $48 plus 60. Ooh, wrong. I swear I know what I'm doing, guys. I don't know what's going on here. Three times 65. Two, 6. These pretzels are making me thirsty, guys. Something is happening here. I don't know what's going on. All right. 2 times 108 minus 3 times 65. It's coming out to be 21. Why is this coming out to be 21? What did I mess up on here? 12 times 5 plus 3 times 16 is 108. Did I mess up here? 12 times 3. I deep mind that. 12 times 3 plus 16 times 2. This is 68. That's where the mistake is, guys. Why did I get 65 there? I'm sorry. That's all I can say. I'm sorry. This is bugging me. All right. So now I'm going to double check. 108 times 2 minus 3 times 68. And now we do get the 12 that we should have gotten. Ugh. My apologies, folks. I was like, again, you're seeing the nuts and bolts. You're seeing the wheels come off. It's the end of the chapter. And then negative 324 plus 68 times 5. Oh, that's why. Okay. Negative 324. Negative 324 plus 68 times 5. We get 60. So we end up with the same answers. I swear the rest of the lesson will go a whole lot smoother. So with this, we got the same numbers that we started with. So that way the receiver knows what's going on. You know, granted that something didn't happen in the computer program. So why does this work? Why, when I take these numbers here and I multiply them by some encrypting matrix, if I multiply it by the specific decrypting matrix, why do I get this back out? Well, it's very simple. The encrypting and decrypting matrices are, did you figure it out yet? You had enough time because I was stupid. Inverses. They're inverses. That's why this works out. Because if I take some matrix times some matrix A times the inverse of A, these two guys are just going to become the identity matrix. So one undoes the other one. It's like adding 3 and then taking it away. It's like giving you $3 and then taking $3. That's what's happening here. Is these guys right here ultimately end up, I'm just going to change colors here, ultimately end up undoing one another. That's why this works. So again, I went ahead, I took another word here. I took apples. So 1, 16, 16, 12, 5, and 19. I went ahead and I turned this. Now, you can also go ahead and you can chunk this into one big matrix here. And then we can go ahead and multiply that times the encrypting matrix. Again, I just picked seemingly random numbers. And we'll end up with this right here, negative 44, negative 29, 28, 24, negative 37, and negative 23. So now, if I take that message, if that's the message that's going out, but I want to receive this, how can I decrypt this problem? Well, in order to decrypt this problem, all I simply need to do here, just go ahead and find the inverse. So to find that inverse, again, first I'll need the determinant. So in this case, the determinant here is negative 8 minus negative 9. So, oh, hey, look, my determinant is 1. That's convenient. It's like I planned that. So we end up with, we'll switch those guys, negative 2 and 4 right there. Change the signs on these guys, negative 3 and 3. There's our decrypting matrix. So if I know the encrypting matrix, I can actually find the decrypting matrix relatively easy. I just got to find the inverse. So then I can go ahead, I can take that. Oh, I already got it there. And then multiply and see that I get the same message coming back. How do you like them apples? Because it was apples. I wrote that joke last week. So pretty powerful stuff. Pretty powerful indeed. So with that in mind, here's what I want you guys to understand is that, I mean, we kind of need this. We kind of need to make sure that what's flying out there that we don't want other people to see is protected. And that's why the idea in a digital age without cryptography is just anarchy. Because there was, I don't know if you've ever seen the movie Ferris Bueller's Day Off, but like the vice principal called Ferris Bueller, called his mom and was like, oh, your kid has like 20 absences. She was like, what, 20 absences? No, he doesn't. And then while he was looking at it, Ferris was able to go in to the computer that he was using and change the number to down to 2 or whatever. I don't know what he changed to. But right there, that's because there was no cryptography. Yeah, nothing would be secure. If you just plug in a computer without any kind of protection, anybody can do that. Anybody can hack in. Again, that's why we have firewalls and things like that, to make sure that people can't just easily tap into your computer. So if we were in class, here's what I would tell you right now is that I would say, hey, I went ahead and I encoded some message for you. So again, some message, and this was what I encoded it with. And then I would say, find this message. That's what I still want you to do. I want you to still go ahead and figure out this message as if we were in class. Okay, so hit that pause button. Like I said, this video is still going to be under 30 minutes, even with all the mess ups I had. So go ahead and hit that pause button. Try to think about, okay, if I know the encrypting, I need the decrypting. Think about what that is. Okay, then once I have the decrypting, I can just go ahead and multiply. Now you can make all these, again, you can make this 6 smaller matrices, or you can make this just one big matrix and multiply. I multiplied on the right side, you'll multiply on the right side as well. That's something else I should say. So with that in mind, go ahead and try this problem on your own. Hit that pause button. Great, now that you're back. So in order to find the decrypting matrix, again, we need that inverse. So there's our decrypting matrix. We have -4, 7, 3, -5. Because I set it up so the determinant was -1. So after your switching of all that, you'll multiply by -1. Here will be your decrypting matrix. Then we go ahead and multiply, and we end up with these numbers right here. Now we just need to translate them. A is 1, B is 2, so on and so forth. And we will see that I wanted you to enjoy your day. And that is what I want you to do. Enjoy your day. Now, before I let you go here, because like I said, this video is still going to be one of the shortest lessons we've ever had. So before I let you go here, here's what I will tell you is that I'm not putting this on the test. I know this is an application. I want you guys to understand the importance of this as an application, but I ultimately, again, I want you to know this. I want you to understand this, so that way if somebody's talking to you about the importance of security and things like that, you have an idea. But like I said, in terms of showing me that you can apply this, that's a little bit tougher, because like I said, this is just such a bare, like, surface scratching. Like there's a good 5 miles deeper we could go when it comes to cryptography and what this really does. Now, we did this very simple, because you might be thinking to yourself, well, Mr. Keith, this feels really simple and basic. And yeah, here's the thing is that I can tell you right now, I mean, credit cards are 16-digit numbers. Credit card companies are using 16 by 16 matrices to encrypt that information. So the larger the matrix, the harder it is to crack that matrix. And then there's things with prime numbers, and like I said, there's so much more stuff that, again, I'm not going to jump into everything. But that's the main takeaway I want you guys to have with this, is making sure that you know that, yeah, I was like, the bigger the matrix, the harder this thing is to crack. So that's all I got. As I said already, enjoy your day. On that note, I will bid you adieu. Until next time, stay safe out there after.